special right triangles. The first one is 45, 45, 90. The second one is 30, 60, 90. You only use these properties when you have a 45, 45, 90 or a 30, 60, 90. Otherwise, if it's a right triangle, what do you use to find the side lengths?
Pythagorean theorem.
Pythagorean theorem. Take a point. Now, we're going to create a 30, 60, 90 from an equilateral triangle. What do you know about equilateral triangles?
They all the same size. All the same.
All sides congruent. Alright, what do we know about the angles?
They're all the same.
All angles are congruent. What do we know about the measure of the angles?
All equal the same.
Well, if they're congruent, what are they?
The same.
They're all 30.
30 plus 30 plus 30 is not 180. What's the sum of a triangle?
60.
They're 60. All angles are 60 degrees. Both of you get a point.
Okay. I said, do not let Sean Paul touch the stuff. That's what y'all do. Let him touch it.
Okay, so what I want you to do is I want you to call this A, B, T.
There it is.
Because I like to party. Alright, and then I want you to label that this angle is 60. And this is 60. And this is 60.
I'll put C.
Ham sandwich. This whole side length is 2.
Wait, what?
Please, just keep talking.
Alright.
I know, mister. Alright, so what we're going to do is we're going to draw an altitude. What is an altitude?
The height.
Yes, but what is it? What does it do? It cuts the angle in half, and then what does it do to that side? Good, take a point. So if it cuts 60 degrees in half, what is the angle ABZ going to be? 30. And what is TBZ going to be? 30.
Why not make them like where they make more high?
Alright, so because that would mean this whole angle, and I want to show that the two angles are congruent. Now, it also cuts this side right here in half. So we're going to call this K. And what would AK be? Why?
Because it's in half. And the half of 2 is 10.
Awesome. So what we're going to do now is we're going to find the length of this altitude. Now, the first thing we're going to do is we're going to come down here and redraw our triangle. So please redraw your triangle. And if you need to use a ruler, use a ruler. Then write on your paper.
Wait, why did you draw half? You said redraw ours. Like, that's when like the whole triangle.
Except for because
You draw half.
Alright, what did we say the length of AK was?
1.
Good. And what's the length of AB? 2. Why is it 2?
Because all sides are congruent.
Okay. Now, if we are missing this side, what do we use to find the missing side length of a right triangle? Okay. So that's A squared plus B squared equals C squared. No, you're not, darling. What goes in the place of A? Alright, what goes in the place of B? No.
Nothing. B squared.
X or B squared. Why does 2 not go where B is?
Because the wrong side.
It's the hypotenuse.
Yeah, she knows your child.
It's crazy what happens when you don't talk for a minute and pay attention. Alright, what is 1 squared? Alright, what is 2 squared? I do subtract 1. And you get x squared equals? How do I get rid of the squared? Square root it. Good. Now, do I want you to take the square root of 3 and get a decimal, or do I want you to leave it in simplest radical form?
Simplest radical form.
Simplest radical form. So x equals root 3.
Look at this guy.
Great job, Taters. Now, what do you notice about 1 and 2?
2 plus 1 equals 3.
Thank you.
I was like, so true.
I know. How did we get 1?
We cut that 2 in half.
Okay, so what do you notice now about 2 and 1?
I'm just gonna stop talking.
You just...
I just said it.
No. Jesus Christ. How did we get the 1?
We cut 8.
We cut 2 in half. So half of 2 is, and that's going to be the relationship every time. Now let's prove it and see. Thank you so much. All right.
She's gonna give you the thing. She'll go walk. I don't think she can. See how she treats us like this? I know she like.
All right, let's prove that that is a true statement. Draw this. If this is 6, and we're going to pretend that my 6 looks like a normal 6, what is the length of our hypotenuse going to be?
3. Oh, 12. Sorry. I didn't know where you put it. Because you cut it in half. You cut.
Remember how we cut 2 in half to get 1?
Yes.
So we would cut 12 in half to get 6, which means you would do 6 times 2 and get 12. 6 times 2 is...
Oh my goodness.
I wrote it on the paper.
Oh, you just came up with the number?
Yes.
Okay. That makes more sense.
And this is x, and I want you to find x. That was so painful for no reason.
I know how you do it.
I know, baby, but you can do this. Come on.
I know how you do it. I'm tired.
Pythagorean theorem. Let's go, let's go, let's go.
I always forget the squaring, and I think that's why you broke her flower. Oh, wait, that's not weird.
It comes off.
No, it's not. You broke it.
No, that's how you replace the tape.
I feel like she's gonna lose it. Let me just move my. I thought you was the one that
I just want y'all to do this problem.
You still got the tape.
You read
Remember, you need to get in simplest radical forms to find the biggest perfect square that divides into it.
Oh. 36.
I would go down to chase.
What?
36.
What about it? You're just saying numbers at me. Like, I don't...
So we don't do Pythagorean theorem?
Yes.
Then what's the 36?
Yeah, honey, you get x squared plus 6 squared equals 12 squared, right?
36.
So that's x squared plus 36 equals 144. I still don't know why you're just saying 36 over and over again.
I thought you was the 6 squared.
No, honey, I'm not. I'm putting this because she wanted the card so that she could divide her biggest perfect square into whatever number she got.
Oh, never mind.
What are you talking about?
It's
the Pythagorean theorem. It does not matter which one goes in which leg. They're both legs.
That was just when we first started.
Okay, this one you're not gonna do.
This is 36.
Are you jealous?
Ish.
It was just a clap, you know,
Is
so I'm
it
gonna
six
accept
then?
that, but you know. Anything more than 70.
Oh, that's okay.
Supplement.
So you broke 108 down into 36 and 3, right?
Yeah.
But then you have to take the square root of 36. What's the square root of 36?
6.
So it's 6 root 3.
Got it.
Now, it is going to be that every single time. That same pattern every single time. Turn your paper over. So if this x is 5,
What?
what's this side length right here going to be?
5 root 3.
And what's this side length going to be?
10 root 10.
Just 10, because it's 2 times 5. You should write this down. So this is across from your 30-degree angle. This is across from your 60. This is across from your 90. So if this is 7, what's across from my 60-degree angle?
7.
I don't know why I said 7.
And 14.
You were trying to get there and I heard you and I was just waiting, hoping that you would fight your way there. And then this would be 14. If I gave you 9, what would be across from my 60-degree angle?
3.
And what's across from my hypotenuse? Have a good weekend. Alright, we're going to finish on Monday. You have no homework this weekend.
God